Fori Automation specializes in fully integrated MIG welding applications. Systems include both steel and aluminum designs, primarily for underbody applications such as engine cradles, trailing axles, frames, exhaust systems, and suspension components. Fori's engine cradle welding and machining system is featured today. This system is comprised of several sub-assemblies: Fori's common overhead transfer system, power and free conveyance, multiple aluminum welding cells, and multiple machining stations. The operator loads the individual front engine cradle pieces onto the weld station and presses the two-hand safety button. The fixture clamps the components and advances them to the welding position. The fixture indexes to the weld station. The robots then advance and begin welding. The servo-positioned trunnion allows optimized weld orientation in conjunction with specific robot path programs. After the first stage of welding occurs, the fixture rotates to allow the robots to weld the side of the engine cradle components. After the second welding stage, the fixture rotates again to allow the robots to weld the underside of the engine cradle cross members. When all welds are complete, the entire station indexes to allow the operator to remove the welded subassembly. The front and rear engine cradle crossmember assemblies are loaded with side rail members in the third welding station. The operator presses the start button and the overhead transfer descends, clamps, lifts, and transfers the components to the weld cell. The overhead transfers load the engine cradle into position to be welded. The robots advance and begin welding. After the first stage of welding occurs, the fixture rotates, allowing the robots to weld the side of the engine cradle components at an ideal attitude. This particular engine cradle is made of aluminum, thus orientation of the weld joint to gravity is critical. The fixture rotates to the third welding stage, allowing the robots to weld the underside of the engine cradle. The chain and gear-driven conveyor system moves the transfer pallets to each welding station. When they reach the end of the conveyor, they rotate underneath and return to the start of the weld line. A selectable stop lever with an anti-backup device stops and holds the transfer pallets to let the overhead transfer system clamp, lift, and return the cradle securely. Once seated properly, the stop lever is released. The cradle and pallet are transferred to the next station. After all welding is complete, the conveyor advances the engine cradle to the etching station, where important information such as part number, Julian date, shift number, or line numbers are etched into the cradle. The cradle travels to the inspection station, and the operator lowers the fixture onto the cradle. The operator visually inspects the welds, and the cradle is lowered back to the transfer pallet. The transfer pallet and engine cradle travel to the end of the conveyor, where a robot clamps and lifts the cradle off the pallet. The pallet then travels on the underside of the conveyor to return to the start of the cycle. The robot places the engine cradle onto a cooling buffer to be loaded into the machining system. The load robot clamps the engine cradle from the cooling buffer and positions it onto the machine line transfer system. The conveyor shown in the background transfers metal debris to a reclamation bin. The engine cradle is transferred to the CNC station, where the tools advance and machine the ends of the cradle. Slots are machined into the cradle at the same time holes are drilled. The cradle is rotated to allow the overhead transfer system to deliver it to the next station. At the first of 2 piercing stations, the cradle is clamped into position. The heads advance and pierce the cradle. The second station pierces and hydraulically swages threaded inserts that are provided from a vibratory feed system. The overhead transfer system moves the cradles through the machine line as seen here. The engine cradle enters the probe station where quality tests are performed. The operator can monitor all quality tests. An offload robot moves in and clamps the completed engine cradle. The engine cradle is removed, rotated, and placed in the unload rack. Cradle machining is now complete. Fori also designs and builds turnkey automation systems for exhaust pipe welding. The exhaust pipe assemblies are loaded onto a turntable that is then indexed to the welding area. The robots weld the first section of the exhaust pipe to the expansion chamber. The turntable indexes and another cycle begins. The second stage fixtures move the components into position and the robots weld the units together. Fori Automation will design a system based upon your specific product requirements, including your choice of robots, weld systems, control systems, and other preferences. Production volume ranges and manpower requirements will be accommodated at any level.
This concludes our video presentation. Fori Automation also designs and builds systems for tire and wheel assembly, wheel alignment, headlamp aiming, chassis marriage, frame handling, vision inspection, and much more. For more information, contact the world leaders in automotive manufacturing technology, Fori Automation, when innovation and performance count.